Good morning. Today we're going to talk about section 3.3, continuing with chapter 3, entitled Problem Solving Using Systems of Two Equations. That's the author's title. I entitled it Problem Solving Using 2x2 Systems, of course, meaning two equations with two unknowns. All right, there's three examples that worked out in the book that I want to go over in this video lecture. And all the homework problems and eventually the test questions are going to be modeled after these three types. I want to first cite example 1 on page 247. Now, when you talk about problem solving, that's kind of a code word in this text for word type problems or story type problems. So you may want to pull out the book and get familiar with the problems before we go on, pause if necessary. I'm going to state the problem here, read it right out of the book. Example 1, pets. In 2007, there were 163 million dogs and cats owned in the United States. If the number of dogs was 13 million less than the number of cats, how many dogs and how many cats were owned in the United States that year? Well, any word problem needs a clear let statement before we do anything else. We're looking for two things here, really, the number of dogs and the number of cats using the given information. So our author says let x equal the number of dogs in millions, and then y we're going to let be the number of cats in the United States, of course, in millions. Alright, well, the idea here is to squeeze two equations with two unknowns out of this given information. And the first equation we might grab out of this is pretty simple. If there's 163 million dogs and cats owned in the United States, well, that of course implies that the number of dogs plus the number of cats equals 163, of course, in millions. Okay? Alright, now we're given a second bit of information here. It says the number of dogs was 13 million less than the number of cats. The number of dogs was or is 13 million less than the number of cats. So I'm going to say the number of dogs is 13 million less than the number of cats. So I can then say x equals y minus 13. Number of dogs equals 13 million less than the number of cats. Alright, so that gives me two equations with two unknowns, and I think this system cries out to be solved with the substitution method since x is already solved for. It's a simple matter then to substitute y minus 13 for x in the first equation, and I get the resulting equation with one variable, y minus 13 plus y equals 163. Of course, if I combine like terms on the left and add 13 to both sides, I get 2y equals 176. Of course, then y must be 88, dividing both sides by 2. And remember, y was the number of cats. So I'm going to say 88, y is 88 million in cats, right? And it's a simple matter then to substitute this value of 88 into either of these equations and solve for x. So I'll pick the second one. X equals 88 million minus 13 is, of course, 75 million in dogs. Alright, so our solution is, well, let's see, number of cats is 88 million, if I want to summarize this clearly, and the number of dogs is, of course, then 75 million. And there's my solution. Alright, so that one wasn't too hard to follow. Let's go up the ladder, and I want to do example 5 on page 251. So you can follow along with the author's solution as well as the video lecture. Example 5, page 251. Again, the goal is to get a 2x2 system that we can solve either with the substitution method or the elimination method. Let me turn there myself. Example 5. Interest income. Alright, to protect against a major loss, a financial analyst suggested the following plan for a client who has $50,000 to invest for 1 year. Let me write that down. We've got $50,000 to invest for 1 year. Okay. Alright, they number these possibilities. Alco development builds mini malls, high yield, 12% per year. Number 2, certificate of deposit, CD, 4.5% annual interest. Alright, basically we've got two accounts to divvy up this $50,000 in. There's an Alco investment and a CD investment. The Alco investment is 12% per year. The CD investment is 4.5% per year. That's a point there. All right. And the idea here is how much to invest in each of these. All right. Well, it says at the very bottom of the page, if the client puts some money in each investment and wants to earn $3,600 in interest, how much should be invested at each rate? So the total interest we need has got to be $3,600. All right, how much should be invested at each rate? That's the question. All right, I'm going to write a let statement here. Let X equal the amount put in the Alco investment, and I'm going to let Y be the amount put in the CD investment. And we have to find out the dollar values of each to come up with $3,600 in interest at the end of the year. Well, clearly, the total amount invested is got to equal $50,000. That's how much we've got to invest in each. Alright, so that's one equation down. And what I'm going to do now is set up an equation regarding the interest in each account. Let me write this out in words here. Interest from the Alco account plus the interest from the CD account has got to equal the total interest drawn from both accounts. Now, of course, we know that interest equals principal times rate of interest. So the interest from the Alco account, well, the Alco account is at 12%, so I can say that 12% or 0.12 times the amount in Alco is got to equal the interest from the Alco account, plus the interest from the CD account. Well, the CD account is 4.5%. In decimal, that's 0.045 rate of interest times the principal in the CD account. That's the interest from the CD. Has got to equal the total interest. Well, that needs to be $3,600. Alright, so using now these two equations, I can get a system which hopefully I can solve either by elimination or substitution. I think we're going to use substitution here. Alright, this is solved in the book, so I'm going to get a new screen and rewrite those two equations. Give me a minute here. Scroll up. Alright, so I've got x plus y equals 50,000. And then 0.12x plus 0.045y, that's my interest equation, has to equal $3,600. There's the system I have to solve. I'm going to use the substitution method. Our author uses the substitution method, and what the author does is takes this top equation and solves for y. So y equals 50,000 minus x, and then I'm going to substitute that expression for y into the second equation and hopefully solve for x without too much trouble. So 0.12x plus 0.045 times 50,000 minus x has got to equal 3,600. Alright, we've got some decimals here, and just like with fractions, I'm going to try to get rid of these decimals in one swoop. If I multiply by 1,000, all these decimals will go away. Notice 0.045, that means 45 1,000ths. So I'm going to multiply both equations, or this equation, both sides, by 1,000. Alright, so basically I'm going to take each term here and multiply by 1,000 on both sides. 1,000 times 0.12x will give me, well, 1,000 times 0.2 is of course 120, so I'll get 120x plus, alright, this expression, multiplication is associative, so I can multiply 1,000 times 0.045 and then multiply by the remaining 50,000 minus x. Well, 1,000 times 0.45 is simply 45 times the remaining factor, 50,000 minus x, and I'll worry about that in a minute, equals, well, 3,600 times 1,000 is going to be 3,600,000. Okay. Alright, things are looking better now that I've got rid of those decimals. I'm going to go ahead and perform my distributive law on that second term. I'll get 120x plus, well, 45 times 50,000 is going to be 2,250,000, using my calculator, of course, minus, don't forget about 45 times minus x, gives me a negative 45x, equals 3,600,000. Alright, of course, now I'm going to combine like terms. 120x minus 45x gives me a 75x on the left, and I'm going to subtract 2,250,000 from both sides, and that will give me a 1,350,000 on the right. And if I divide both sides now by 75, using my calculator, of course, I get a solution for x of $18,000 in dollars. So I'm going to say $18,000 in, well, x, you recall x was the amount in the ALCO account. Alright, now I'm going to use that x value to solve for y, and of course I'll want to use this top equation now to solve for y. So y then equals 50,000 minus 18,000, and of course y is then $32,000, and of course that's in the CD account. So I've got $18,000 in the ALCO account and $32,000 in the CD account. Alright. One more example, actually two more I'm going to do today. Next one I want to talk about is example 7. Hang on a minute. This is example 7. Again, worked out in detail by the author on page 254. You might want to familiarize yourself with the problem before we go on. And of course, I'll read it here. Example 7. This is what we call a mixture type problem. Example 7, popcorn. A tin of jalapeno flavored popcorn sells for $36, while the same size tin of cheddar cheese flavored popcorn sells for $24. How many tins of each type of popcorn should be used to create 10 tins of a mix that can be sold for $27 per tin? Alright. Again, I'm going to show a clear let statement before I do anything else. Let X equal the number of jalapeno tins, and Y then would of course be the number of cheese flavored tins. And we know that there has to be a total of 10 tins in the final mix. So X plus Y has to equal 10. Alright, so that's an easy equation to grab right off the bat. Now I'm going to set up what I call a value equation. Let me write it out in words. The value of these cheese tins plus the value, let me put the jalapeno first. I believe the author puts the jalapeno first. The value of the jalapeno tins plus the value of the cheese tins has got to equal the total value of all the tins combined, right? Well, what is the value of the jalapeno tins? Well, you've got X jalapeno tins, and they sell for $36 each, so that means the jalapeno tins add $36X to the final mix. The value of the cheese tins. Well, we've got Y cheese tins, and they sell for $24 each. Alright, so 24 times Y, whatever Y ends up being, will be the value of the cheese tins. And the total value of all these tins, well, the book states that we want to create 10 tins worth $27 each. So it's going to be 10 tins times $27 is going to be the total value of the mix. Alright, of course I can get a nice equation out of that. Let me write it out here. 36x plus 24y equals 270. Alright, so I've got two equations involving two unknowns, which I should be able to solve pretty easily. Let me rewrite the system here. X plus y equals 10, and 36x plus 24y equals 270. There's the system I have to solve. Now, our author uses the elimination method. I suppose you could just as easily use the substitution method. I suppose it's up to the student which method you want to use. Sometimes there's an advantage to one method or the other. Here I don't think there's any glaring advantage to one over the other. Alright, what I'm going to seek to do is eliminate the y variables. I can easily multiply the top equation through by negative 24. Alright, so multiplying the top equation through by negative 24 gives me this top resulting equation. Of course, then I'm going to add that to the bottom equation, we see a nice setup to eliminate the y variable here, right? Adding these two equations, I'll get a 12x in the first column plus 0, of course, equals 30. And I can easily solve that for x. Looks like I'm going to get a fraction here. X equals 30 over 12, which of course reduces to 2.5, or I'll call it 2.5 tins. Remember, x was the number of tins of jalapeno. I'll then use my top equation here to solve for y. So if x is 2.5, then 2.5 plus y must equal 10. And of course then y equals 7.5 tins of the cheese popcorn. Alright, so let me summarize the results neatly here. I'm going to say there are 2.5 tins of jalapeno popcorn, and there's 7.5 tins of the cheese flavored popcorn. And there is my final solution. Okay? Alright. Alright, the next one I'm going to talk about, and it's the last one today, another mixture type problem. This is example 8. Again, worked out in detail with many pretty pictures on page 255. So let's familiarize ourselves with that problem. Water treatment right on the bottom of page 255. A technician determines that 100 fluid ounces of 15% acid needs to be added to the water in a swimming pool to kill the growth of algae. If the technician has 5% and 25, if the technician has 5% and 20% solutions on hand, how many ounces of each must be combined to create a 15% solution? Alright, so basically the situation is this. We've got a certain amount of 5% solution that we want to add to something stronger, a 20% solution, to end up with a 15% solution in the end. Okay, so that makes sense. You got something a little weaker, something a little stronger, to end up with something in between, and the idea is how much of each to add. Well, it's important to note that we want to end up with 100 fluid ounces in the end. So our final solution is going to have 100 ounces at 15% strength. I'm going to let X be the amount we put in at 5% and Y be the amount we put in at 20%. And of course the question is, to solve for X and Y. Alright, from this diagram I can see that the volume of X ounces plus Y ounces has to equal 100 in the final solution, right? Alright, what I'm going to do now is set up a, what I call a pure solution equation. Let me write this out in words. The amount pure of pure acid from the 5% plus the amount of pure acid in the 20% solution has to equal the total amount pure solution in the final mix. Okay? And I can get an expression for X and Y out of that last equation I've written there. Well, what's the amount pure from the 5% solution? Well, you've got X ounces at 5% strength, so I claim the amount pure from the 5% VAT is 0.05 times x. Okay? Plus the amount pure solution in the 20% VAT. Well, that's going to be 0.2 or 0.20 if you like, times y. And that has to equal the total amount pure acid in the final mix. Well, the final mix is intended to be 15%, and 100 ounces is that volume. Okay? Alright, so I've got two equations now. X plus y equals 100. And this equation here. And I should be able to solve that without too much difficulty. Let me rewrite that system. X plus y equals 100. And 0.05x plus 0.2y equals 0.15 times 100. Well, 0.15 times 100 is, of course, going to be 15. Alright, so there is the system which I need to solve. Alright. I'm going to use a substitution method here. Our author uses a substitution method here. Because I can easily take this first equation and solve for y. Y equals 100 minus x, does it not? And now I'm going to take that 100 minus x expression, substitute it in for y in this equation, and solve for x, right? Let me get another screen here. I'm going to say 0.05 times x plus 0.2 times y. Well, y is 100 minus x with that substitution, and that has to equal 15. Alright, I see if I multiply both sides by 100, I'll be able to get rid of all these decimals. So I'm going to multiply all three of these terms by 100. And the goal being to get rid of the decimals. 100 times 0.05x is going to be 5x. Plus, alright, now this is a product here, this dot I'm drawing right here, that's a product, so I can multiply 100 times 0.2 first, and then multiply by the remaining 100 minus x. So 100 times 0.2 is, of course, 20 times 100 minus x. And, of course, 100 times 15 is 1,500 or 1,500. So, with some good housekeeping, I've eliminated decimals and got something not too terribly difficult at this point. Alright, I'm going to clean things up here. Expand the indicated products. 20 times 100 is 2,000. Minus 20 times x is 20x. And that equals 1,500. Of course, now I'll combine like terms. 5x minus 20x is minus 15x on the left. If I subtract 2,000 from both sides, well, 1,500 minus 2,000 is, of course, minus 500. I'll now divide both sides by negative 15. The negative 15s cancel on the left. I get x equals, well, 500 over 15, positive, reduces to 100 over 3. And I'm going to go ahead and approximate this with decimal. Our author does not. I'm going to say this is approximately 33.33 ounces. And remember, X is the 5% solution. Alright, so we've solved for X. Of course, we know that X plus Y must equal 100. So I can say 33.33 ounces plus Y equals 100. And Y is, of course, then 66 I'll call it 67 ounces, rounding off. Okay? Alright, so not too bad. My final solution then to this system of equations, I'll say there's 33.33 ounces of the 5% acid solution, and hence there's 66.67 ounces of the 20% solution. There is my final answer for how much of each solution to use. Alright, so we've done I think 4 of these, and we'll call it a day. For this section, concludes section 3.3, problem solving 2x2 systems.